This is ENME 351, Lab 6, Digital Analog Conversion and Servo Motors by Garrett Schweitzer. This is my servo demonstration. So as you can see, my potentiometer controls it through a full 180 degrees of rotation. I found that for this potentiometer, we want delays of between 600 and 2300 microseconds to get a full 180 degree rotation. And as you can see in my code, I made a linear relation for the 0 to 123 value read from the potentiometer to degrees, and then I had another linear relationship for the delay time that I required from the degrees that we found previously. Now for the digital to analog conversion segment. So as we can see, the circuit, the calculations for the circuit are relatively straightforward. So we have 8 bits overall. Now we have 5 volts being input into our circuit, so we need to find the voltage per bit. 5 volts over 8-bit is 0.625 volts per bit. So then we can assume that with everything turned off, all 3 switches, we're going to have 0 and then increments of 0.625. As you can see, we are heading down the list until we reach 4.375, which is our highest voltage achievable. Now I'll demonstrate 3 different states for the switches. 3 different unique states. So here we have with our leftmost switch off 3.75, which is accurate to our readings. With our rightmost switch also turned off 1.25, which is accurate to what we had found. Everything off, we have 0 volts, and with our only leftmost switch turned on, 0.625 volts, which are our least significant value. Here's a demonstration of my digital analog converter. So these are wired backwards from what is on the table there. So my rightmost is actually bit 1, least significant bit. So with that on, the rest of them off, we're getting 0.6 volts, which is just about what we should be. With that off, we're getting 0 volts as we should. With the most significant bit on, we're getting 2.5 as expected. And then we'll move the middle bit on, 3.75 as expected. All 3 on, 4.36, which is just about 4.375 as we expect. Related to the last test, all of my voltages lined up very well to what I expected, but there was some error because I'm storing most of these values as integers, but doing math with floating point issues with some of the connections are a little spotty. Here we can see my DAC and my servo hooked up. So we'll move my least significant bit, change that to 1 to on, move a little bit, move the next most significant bit, we're closing to 90, move the most significant bit, we're at 180 degrees, move that back. So it's working as I expected, and I achieved this by basically having a couple if statements to adjust the degrees. So if the red value was between a range, it would set a degree to 1 of 8 possibilities. As you can see over here on my Excel sheet, I did disregard this. Sorry, this is actually 5%. So I found the 1023, divided that by 8 to get the 8 different possible values that we should expect, and then gave 5% on either side of that, and programmed that in here to my Arduino code. So basically, if I'm within this 5% range for any of these values, I will go ahead and set the degrees accordingly, and then that is converted into the delay down here, so we can properly pulse width modulate for the servo.